Good morning. This is Unit 5, Day 3 Notes, and we're going to go over arithmetic and geometric sequences. So an arithmetic sequence is when we're going to add or subtract a number each time. So it says every term is formed by adding a constant number to the preceding term. So this one, to get from 7 to 14, it looks like I'm going to add 7. From 14 to 21, I'm still adding 7, and from 21 to 28, that's still plus 7. From 48 to 39, we're going down. So we're not adding, we're subtracting 9. From 39 to 30, we're still subtracting 9. And as long as we subtract 9 each time, then that is going to be an arithmetic sequence. A sequence is an arithmetic sequence if there is a constant. We're going to name it D, for which U sub n, this is a recursive formula, is equal to U sub n minus 1 plus D. And D can be positive or negative. This is called recursive. Alrighty. For all integers of n is greater than 1, D is the common difference. Of the sequence D equals U sub n minus U sub n minus 1. So we're going to take the second term and subtract the term before it. It says the nth term of the arithmetic sequence, the general or explicit term or nth term of an arithmetic sequence U sub n with first term, we usually say U sub 1, U and then sub 1, and common difference, we said the difference is D, may be expressed explicitly as U sub 1, the first term plus, and then n minus 1 times D. This is a very important formula, so highlight it, circle it. U sub 2 is equal to the first term plus the difference. U sub 3 is equal to whatever U sub 2 was plus the difference. We can also write this as U sub 1 plus the difference, right? Same thing. U sub 4 is U sub 3 plus the difference. The one before it plus another, plus the difference. Or we can rewrite this as U sub 1 plus, this is 2D plus D, and it would keep going. U sub 3 is U sub 1 plus 2D, so this is D plus D, so this is 2D. And then this is 2D plus D is 3D. So this is going to be, the fourth one is 4 minus 1, right? Or the one before. So it will be U sub 1 plus n minus 1 times the difference. That's how we get this formula. Let's try a couple of problems. Say whether each given sequence is an arithmetic sequence. If yes, find the common difference and the 50th term. So we want two things, the difference and the 50th term. Two things. All right, a sub n equals 2n minus 3. So if this is n, let's make a little chart. Then let's find a sub n, or our y. I'm going to try when n is 1. When I plug in 1 into here, I get 2 minus 3, which is negative 1. Okay. I'm going to try when n is 2. I get 4 minus 3, which is 1. When n is 3, I get 3. And when n is 4, I get 5. Now I need to know if the a sub n's are going to be arithmetic. So if I go from negative 1 to 1, I'm adding 2. From 1 to 3, I'm adding 2. Ooh, and from 3 to 5, I'm still adding 2. Perfect. So we're going to say yes. This is an arithmetic sequence. All right, my difference is 2. All right, and they say find a sub 50. Okay, a sub 50. Well, we have a formula for this. I just wrote it right here. A sub n, but they want the 50th term. So a sub 50 equals a sub 1. Ooh, a sub 1 is the first term. And we know that that is, the first one is negative 1 plus 50 is our n minus 1 times the difference, which is 2. And this gives us 49 times 2 minus 1 is 97. Or we could have just plugged 50 into a sub n because this is a formula and that would have given us the same thing. So a sub 50 equals 2 times 50 minus 3. Ooh. Alrighty. Now let's look at the next one. This one is, let's just make our chart. When n is 1, we're going to, actually we need to start with 0. So we're going to have to let u sub 0 just equal 0. Then u sub 1 is equal to 3 times the one before, which was 0, plus 2, which is 2. Okay. And then u sub 2 depends on the one before it, so this is going to be recursive. So this is the one before it, so 3 times 2 plus 2 is 8. And then u sub 3, we need at least 3 to find out if it has a common difference. So u sub 3 is 3 times the one before it, which was 8, and then plus 2. And this is 26. Uh-oh. Well, 2 plus 6 is 8, so we added 6, right? But 8 plus 6 is not 26. So I think we added like 18. Not okay. So this is not going to be arithmetic. And if it's not arithmetic, we cannot find the common difference. There is no common difference. All right, let's try one that doesn't have a formula. We just have numbers. We've got to find this common difference. I know 2 plus 3 is 5. 5 plus 2 is 7. And 7 plus 5 is 12. So this is not arithmetic also either. All right, let's look at this. This one goes, it looks like it is decreasing. 2 minus 7 is 5, negative 5. Negative 5, ooh, minus 7 is negative 12, perfect. Negative 12 minus 7 is negative 19. Okay, so we're actually subtracting 7 each time. So our u sub 1 is 2. Our first term is 2. And our common difference is negative 7. That's a negative number. So we are trying to find the 50th term. We need to find our formula. So we have u sub n. We need to use our formula. U sub n equals u sub 1 plus n minus 1 times d, right? And u sub 50 is what we want, equals the first term, which is 2, plus 50 minus 1 times the difference, which is negative 7. I would do this first, 49 times negative 7, and then plus 2. In your calculator, try it out. You're going to get something like negative 341. They want us to prove that, in the next page, they want us to prove that this sequence is arithmetic by finding the common difference. So the one, or the second term minus the first term, something like that. If we subtract it, that's the difference. So u sub n minus 1, or n plus 1, is 3 times n plus 1. So wherever there's an n, we're going to put an n plus 1 minus 2. And that equals 3n plus 3 minus 2. And I'm just going to combine the numbers, and that is equal to 3n plus 1. Okay, this is u sub n plus 1. And then the difference is u sub n plus 1 minus u sub n. And we already have u sub n, so let's just find out what this is. 3n plus 1 minus the original, but you've got to use your parentheses and make sure you distribute that minus. 3n minus 2, which gives me 3n plus 1 minus 3n plus 2. I just distributed this negative sign to both. And I'm going to just kind of, 3n minus 3n is just 0. And then 1 plus 2 is 3. So this is the constant. This is a constant. So therefore, it is arithmetic. Like a little proof in here. All right, find u sub 1 and d, the first term and d. So u sub 1 is when we plug 1 in for n. So this is 3 times 1 minus 2, which is 3 minus 2, which is 1. Yay. And then their d we already know is 3. I guess that's it. Find the 57th term. So u sub 57, we have that beautiful formula for us, is well, we can actually just use this. So this is going to be 3 times 57 and then minus 2. Plug that into your calculator. I think that's like 169. Make sure. What is the least term of the sequence, which is greater than 450? This is a really good IB question. So we're trying to find 3n minus 2. Where is it equal to or greater than 450? We really want it to be like right after 450. If I add the 2, I get 3n is greater than 452, and then divided by 3, n has to be greater than 150.6. So we're going to actually have to round up to the 151st term. Okay. This is a good test question, so I'll put a little star by it. Find the k given the consecutive arithmetic terms. Oh, find k. So there's like a missing number here, and we got to find out what we're trying to do. So it looks like we're decreasing. 32 minus something is k, and minus something goes to 3. So we do k minus 32 and 3 minus k. They actually have to be equal, right? 3 minus k and k minus 32 has to be equal. So let's set them equal and find out what k is. This one, I can actually move the k to the right, to the left, and move my 32 to the right. And I'm going to get 2k equals 35. Divide by 2, k equals 17.5. And that can be a decimal, just leave it like this. We don't round. Same thing, 7 minus k has to equal 10 minus 7. So we always start with the second one and go to the one before. Okay, this one is super easy to, this is just a linear function, solve for k. Tell me what k is. Let's try this one. I'm still doing the same thing. The second one minus the first one. So 2k plus 1 minus parentheses k plus 1 has to equal 13 minus 2k plus 1. Just remember to distribute your minus signs. So we have 2k plus 1 minus k minus 1 equals 13 minus 2k minus 1. I want you guys to try to solve this. Pause it, try to solve this video, and I'm going to tell you the answer. See if you get this answer. You guys can go ahead and try this. Let's start on geometric sequences. So just like arithmetic, geometric sequences, you're going to still be using a constant, but this time we're going to be multiplying by a constant. So this looks like we are not just adding 7 each time, we're actually multiplying each time times 2. We're multiplying by 2. This one, it looks like we're multiplying by a negative number. If it goes back and forth from positive to negative, it looks like we're multiplying by a negative number. And maybe a small number. So 48 divided by 2 is 24. 24 divided by 2 is 12. But we don't want to divide. We're going to instead multiply by negative. Don't forget the negative, 1/2. Okay? We're always going to multiply by negative, this time 1/2. So it is decreasing. It's never going to go to 0. But it looks like we are multiplying by a negative 1/2. The definition of a geometric sequence is that there is a constant still, r, this time. We usually use r, for which u sub n equals u sub n minus 1 times r. So this time we can put like a dot or parentheses r, okay? For all integers n is greater than 1, r is called the common ratio instead of the common difference. R equals the second term divided by the first term. Alrighty, the general nth term of the geometric sequence with first term u sub 1 still and the common ratio r may be expressed explicitly as u sub 1 times r to the n minus 1. So we need the term before. U sub 2 is u sub 1 times r. U sub 3 is u sub 2 times r, which is equal to u sub 1 times r, which is u sub 1 times r squared. U sub 4 is the term before, so u sub 3 times r, which is equal to u sub 1 times r times r times r, which is u sub 1 times r cubed. And this is the fourth term. So the nth term is u sub 1 times r to the n, the term before, so n minus 1. Classify the sequence as arithmetic or geometric or neither. So we're going to have to multiply for geometric and add and subtract for arithmetic. It says 2, square root of 2, and then 2 square root of 3. So remember, we take the second one and divide it by the first one. And I'm going to just multiply by the square root of 2 on the top of the bottom to kind of get a simplify this. So this is going to be 2 square root of 6 over 2, and the 2's can cancel. And so my square root of 6 is my r, or my ratio. And as long as we can multiply this by the square root of 6 to get this. So let's try it. 2 square root of 3 times the square root of 6. Is that the same as 6 square root of 2? So that's 2 square root of 18. And 18 is 9 times 2. 2 square root of 9 times 2. So the square root of 9 is 3. So 2 times 3, square root of 2. 2 times 3 is 6. Perfect. So yay, it is geometric. Find k given the following are consecutive terms of the geometric sequence. So this time, k over 7, instead of subtracting, we're dividing. K over 7 has to equal 28 over k. And then, since we have fractions on both sides of an equal sign, I will just cross multiply. K times k is k squared, and then equals, I don't know, 28 times 7? I don't know, 28 times 7. And then when we take the square root of both sides, k equals plus or minus 14. Which one would it be? So we have 7 plus 14 plus 28, so plus 14. I want you guys to try this one. You might have to factor, I'm not sure. Find the general term of the geometric sequence that has u sub 4 and u sub 7. Okay, well, if u sub 7 equals u sub 4 times r, which is 5, times r, which is 6, times r, which would give us 7, then u sub 7 they give us is 192 equals 24 times 1, 2, 3 r cubed. And if I divide by 24, I think I get 8 equals r cubed. And then take the cubed root of that, I know r equals 2. But that's not what they asked us. It says find the general u sub n sequence. So u sub n equals u sub 1 times r to the n minus 1. U sub n. Well, I think I'm just going to try u sub 4 because I don't know u sub 1. I need u sub 1. So u sub n for this one would be 24. So u sub 4 is 24 equals, the first one, I don't know that one, times the ratio, the common ratio we know, we just found out is 2, to the n, well, I know this is the fourth term. So to the 4 minus 1, and 2 to the 4 minus 1 is 2 cubed. So 24 equals the first term times 2 cubed, which we know is 8. I would just divide by 8, and then I know that u sub 1 equals 3. And this is really what I need to make my formula. U sub n equals 3 times the common difference, which is 2, to the n minus 1. This is my formula. This is what they wanted. Okay, we did the same thing, so you guys can try this one. let's try this one. It says to find the following, or consider the following sequence, find the nth term. So is it arithmetic or geometric? It looks like we are multiplying each time, and it looks like it's going from negative to positive to negative to positive. So it looks like I'm going to multiply by 2 times 3 over 2 would give me 3. 3 times 3 over 2 would give me 9 over 2. So it looks like each time, let me make sure this is times negative 3 over 2. Perfect. So my ratio, my common ratio is negative 3 over 2. And my first term, u sub 1 equals negative 2, the first one. So my 8th term, so u sub n equals negative 2 times the common ratio, which is negative 3 over 2, times n minus 1. But we want our 8th term. So u sub 8 equals negative 2 times negative 3, pretend, over 2, to the 8 minus 1 is 7. I would just use your calculator right here, because 3 to the 7th power over 2 to the 7th power, I don't know. And I think 2 to the 7th power is 64, but, or maybe even bigger. So let's just plug this into our calculator, and we're going to get 2187 over 64. So that's actually simplified. Find an explicit formula for the nth term. Oh, this is going to be for the nth term right here. Okay. Find a recursive formula for the nth term. So u sub n equals u sub n minus 1 times r. We know our r is negative 3 over 2. I'm just going to bring that in front. U sub n over 2. Yeah, just times u sub n minus 1. And now we just circle this. Alrighty guys, I want you guys to try the other examples and let me know if you have any questions. Have a wonderful day.